Hello everyone, welcome to another episode of Video Geeks. Hello Henil, how are you?
Y- Yeah, thank you, Dev. I'm all good. What about you?
I'm fine too. Did you forget to edit your last slide because I think we were on the same topic last in the last series. What's
Yeah,
the topic today?
yeah. So, in the previous video of our video geek session, we talked about the sport channel, right? So, I'll be explaining the port channel, but this is the second part of the video where we'll see the details of like the LSEP that we have talked about. We'll talk about the protocol and we'll see how to configure port channel, the very basic structure. So for the viewers who are like first time, for them I'll be revising the what we have seen in the last video, and then we'll move forward to the next second part of this series. So basically the which is the main content of today. So are you ready for it?
Yeah, Henil, sure.
Yep. See, so let me revise you that what we have seen in the last video. So in the last video, we have seen that what was the need of STP, why we need STP at the first place, what was the problem that STP was causing, and from that problem, we have understood that port channels are required and what is the need of what is the importance to have port channels. And let's just see. So we have seen that before STP there was loops in the networks that caused network congestion and broadcast ROMs and all that stuff. Then we have STP, but now STP was causing some of the links to remain idle. So that was wasting our cost that we buy physical links, we invest lots of money, but still the ports are not getting utilized. So what is the point of having such uh, like purchasing such costly switches and such costly ports? So we have seen that in the last video that this was the actual we have scaled up the scenario, and we have seen that lots of links were getting unutilized because of the STP. And we have seen that what is the importance of LAG and LACP. So basically LAG is the port channel and LACP is the protocol which dynamically uh, you can say configure ports to be in the port channel. So today we'll see about LACP a bit more, and this was the lag,
Yeah.
this was these were the required basic what you can say conditions to form a port channel. And remember these three conditions. First was we can we this was the we cannot group two ports that are going from one switch to another switch, but if the ports are going from one switch to another, that means one to one mapping is there, then only port channel will be configured. This was the first condition. Second condition was whatever the ports that we are grouping into one channel, they should have same speed and duplex, and then the same configuration on the both ports. So these were the requirements, and we have seen about the LSP modes. So now let's just move forward to the today's topic, where we'll deep dive into LSCP, and at the end of this video we'll see how to configure port channels. So these are the introduction. We'll explore all about LSCP and lag. First we'll revise lag, then some detail about port channels, and then we'll explore LSCP, and at the last we'll configure the port channel. So let's revise. So first, the LAG stands for link aggregation, or it is also known as port channel. And some vendors, let's say Cisco, they refer as ether channels. So these are three what you can say terms for the one same thing. So we'll take the port channel as a word. Then LACP, which is link aggregation control protocol. So this is basically IEEE standardized protocol that will be communicating what you can say packets to form port channel. And at last, port channel. So let's just see the book is what you can say definition. So port channel, it is actually as a you can call it as a group of multiple physical links to form a logical and channel group. So basically these two are different terms, do not confuse with it. So port channel, that is LAG, and channel group, that is a collection of Ethernet interfaces on a single switch. So this is channel group. Let's say these two ports belong to same channel group. But let's say there are so let's say these two ports that belongs to port that is forming a port channel, but that can belong to some channel group. Let's say channel group 1, and then let's say there are two another ports that can belong to some different channel group. Let's say channel group number 2. So channel group is, you can call it as a alias, and port channel is they are both forming a port channel, but they belong to different channel group. So that's how, that is the way you can configure multiple port channels in a single switch. So that is channel group. So do not mix these two terms. So what was the point of having port channels? The first was massive bandwidth that we have talked about. Obviously, if we are grouping two links, then we'll have, let's say these ports are 10 gigs, then combined bandwidth will have 20 gigs. Then redundancy. Obviously, if we are grouping ports, then one of the port failure will not cause this entire port channel to become shut down. So that is best redundancy. And last was higher utilization. So obviously links will be getting utilized, not blocked by STP. So that way we can utilize the all the links. Then this was you can say what is the port channel. So port channel is nothing but a group of ports. So basically it will form a pipeline. Let's say that we have talked about one port is 10 gig. Then if we are grouping two ports, then the combined bandwidth between two switches, there will be one port called as port channel that will be having 20 gigs of port, what you can say, bandwidth. And when the port channel is configured, it can be configured with the most of the port configuration. Let's say on one of the you can call it as, let's say on normal Ethernet interface, you can configure STP, you can configure VLAN, you can configure layer 3 IP addresses and all that stuff. You can apply all the rules that you can also configure on most of the settings, not all of them, most of the settings on port channel. Now let's talk about LSCP. So LSCP is a protocol that is standardized by IEEE 802.3 AD. So LSCP, which is also a method for two switches to automatically establish and maintain a link aggregation groups. A link aggregation that is lag, or we can also call it as a port channel. So it can configure LSCP, what you can say, compatible ports into dynamic lag modes. So we'll talk about lag mode in next slide, but just for now you try to digest this line. And we'll have maximum ports, the what you can say, maximum ports per lag or per port channel, that varies from vendor to vendor by platform also. So that is one thing to be noted. And let's say when there will be a port channel, there will be a packet exchanges that will happen. So the management of those packet exchanges and formation of what you can say packets, that is called as LSCP negotiation packets, or you can say the packets that are exchanged before they form a port channel, right? So after the packets has been exchanged, they will form a port channel. So that is the communication that happens, that is known as LSCP negotiation packets. And now let's talk about the LSCP modes. In the previous slide, we have talked about these dynamic lag modes. So let's just explore what are the lag modes. So lag, that also stands for link aggregation, and it is same as port channel. So I'm repeatedly telling these terms because you might different people may use different terms. So you just need to be aware about it. And lag modes. So basically there are two lag modes: static lag and dynamic lag. So in static lag, the switches will not initiate the LSCP negotiation packets. It will wait for someone else to send the LSCP negotiation packets, and it will just reply to those packets to form a port channel. And uh, the dynamic lag. So there is dynamic lag also that is supported by switches currently. So what is the dynamic lag? So basically it will initiate the packets. So it will start the communication. It will send the LSCP negotiation packets first. But in that mode also, there are two different interfaces mode that you can configure. One is active and one is passive. So again, active mode is like I will initiate first. Let's say active, if we have configured active interface, then it will continuously send packets until it receives the reply of that LSCP negotiation packet. And passive interface, that is also like uh, it will not initiate the packets, but what you can say, it will wait for someone else to send the packet and then it will reply. So in the dynamic lag and the static lag, so the static lag is like configured. What is the main difference between passive and static? So by the definition, you might think that the passive interface and the static lag is same, but static lag, that is different thing. You configure port channels like it will not allow you to form a port channel until you have configured both the ports. uh, like let's say you configure both the ports to be in static lag. So if let's say one of the side is static, then the other side should be static to form a port channel. And if passive is there, then only then it is compatible with the active, and inside it's a dynamic lag. So that is the main difference. And we'll also see the metrics. Let me just go to the next slide. So this is the lag mode matrix. So as you can see that we have lots of different lag modes. So which mode is compatible with which mode, that you need to be aware of. So there are three modes that you can configure, as we have seen over here. One is static, one is active mode, and another one is passive. So there are three modes, and let's say this is the uh, one switch A and this is switch B port configuration. So if let's say one of the port is active and another port is configured as active mode, then they can form a port channel. One of the port is active and other one is passive, then also there is no problem. They can form port channel. But let's say one port is active and one port is static, configured as static. Then what will happen? So basically this is X. So what X stands for? X stands for link aggregates on the static switches. That means the ports that we have configured to be on port channel, they will be aggregated on the static switch, but not on the other side. So not on this switch, and no port channel is formed. So port channel will not be formed. And if we are talking about passive, then if the other switch is configured with active, then they will form a port channel. But if let's say both the ports have been configured as passive, then there will be no port channel formed. And passive, and if the static is there, then there will be same condition. Static one will form a port channel, but passive one will not aggregate the ports, and the result will be no formation of port channel. And as I have shared, static is only compatible with the static one, no, with not anyone else. You can see. And if one of the side is active, you can see, then there will be a communication. So this is how you can remember this matrix. And this is one of the features that has been what you can say introduced later on, which is fallback mode configuration. So what is fallback mode? So basically when any dynamic mode is configured, let's say if the active mode is configured on to form a port channel, so on these switches, so basically it will not form a port channel until it receives the packets, the reply of LSCP negotiation packets from the neighbor switch. So till then the ports will be on idle mode. But what should be there actually? So all the ports should exchange the packets. because there may be some issues while configuring the stuff. So that is taken care by this fallback mode. So there are also two fallback modes, so static and individual. So what is static? So static is like the port channel maintains one active port while in fallback mode. All its other member ports are in standby mode until a LSCP PDU is received by the port channel. So let's assume that these two ports have been configured with the static fallback. Then one of the port, let's say this port will send a packet and wait for the reply. Meanwhile, this port, the second port, will be idle mode. It will not send any traffic and not receive any traffic. So that is static fallback mode. And once this port has received the reply of LSCP negotiation packet, then this port will start exchanging the packet and normal operation will start. So that is static fallback mode. And fallback mode is supported by timeout. So whenever let's say this port has sent some packet, but it has not got reply for so long, let's say 30 seconds. Then after 30 seconds, if it not receives the packet, then both of the ports will start sending the traffic, but not form a port channel. So that is static fallback. So by the word you can say that fallback, that means fall back to the default configuration. So that is the meaning of this fallback mode. And in static, only one port will be communicating. And now in contrast of that static fallback, there is an individual fallback kind of configuration. In that, let's say if both of these ports have been configured as individual fallback mode, then they both will exchange packets. And if let's say one of these ports has received the reply of LSCP negotiation packet, then they will form LSCP what you can say LAG port channel, and normal port operation will start. So you can see completely opposite to other one, where all the ports will operate as an individual, and when any of the ports receive LSCP PDU, that is the reply of LSCP negotiation packet, so after that normal port channel operation will start. So that is the fallback mode. So let's say this is the active. So that was all about the LSCP and LAG. We have studied some of the definitions and the detail modes, LAG modes, and details of LSCP packet access. So now it's time for practical. So actually we'll explore that practical stuff in this Cisco Packet Tracer. So this is very awesome tool for the beginners. So from here, what we'll do, we'll take two switches. Let's say PT switch. Okay. Now, as usual, we'll dual connect these two devices. One connection and second connection. Okay. Now we'll fast forward this network. Okay. So you can see STP has detected that these two ports are you can say forming the loop, and STP has blocked this port. You can see this is the amber color, so that means this port is not accepting the traffic. So you can see this port is not getting utilized because of this amber sign over here, that this port will not receive the traffic. But if we have port channels configured, these two ports to be in some channel group, then this port will start green triangle over here, and that means that port is that port is able to receive the traffic. So let's configure the port channel. And actually configuring the port channel, that is very easy. What you just need to do, you just need to hit one command. So let me tell you that command. So first we'll go for the privileged executable mode, and now we'll go for the global configuration mode. Once you are in global configuration mode, and you may notice, I'm telling you that these all are Cisco switches. So this configuration is for Cisco devices only, because according to vendor the commands may vary. So let's talk about the Cisco switches first. So let me just hover on these ports. So this is fast Ethernet 0/1, which is connected to fast Ethernet 0/1, and 1/1 connected to 1/1. Okay. So now we go for the interface fast 0/1, and over here to form a channel group, we'll just need to write channel group. Remember, channel group is not same as port channel, that we have seen the difference talked about in one of the slides. Okay, now what we need to do, we need to provide number, and that number should be from 1 to 6. So let's say channel group 1, and after that we can configure the mode. So what should be the mode, right? So there are several options. So options are active, auto, desirable, on, and passive. So according to vendor, the port modes that you can configure may vary, but we have seen the three modes, and that is like active one and passive one. So we'll use these two only, and we'll use active, right? And that same configuration we can do for the interface fast Ethernet 1/1 channel group 1. And remember, both the ports should be, all the ports should be in the same channel group number, then only port channel will be formed. Mode active. Now that is actually it to configure port channel, but remember, the same configuration we need to do on the other switch also. Enable configure terminal interface fast Ethernet 0/0 interface fast Ethernet 0/1 and channel group 1 mode active. Now we'll exit interface fast Ethernet 1/1 and channel group 1 mode active, and that is actually it. And now you can see all the port states are changed because they are currently exchanging the packets and trying to form a port channel. So we can fast forward this network, or that is not needed, because you can see the packets has been exchanged and all of the ports now turn into green triangle. And also we can verify the port channel configuration. For that we can just switch back to privileged executable mode, and from here we can enter show interface status. You can see now, you can clearly see this PO1, that is port channel 1, and also there should be a command for show port channels. There is nothing else. So yeah, I think there is no separate command for port channels. You can directly see it from this command show interface status, and that should be visible port channel 1 PO1. And on this switch also there will be same thing, and we can do exit from the privileged executable mode, show interface status. Yeah, you can see PO1. So that's how you can configure the port channels, and that is the actual configuration for the needed for the port channel. Hopefully you have got the idea about the port channels and all that stuff. So that is, and that actually finishes the video series of the port channels. So yeah, you have any questions there? So yeah, that is all about the what you can say port channels. Hopefully we'll meet you guys in the next video. Till then, keep learning and keep exploring.